Hey, it's Gentle K, your tech guide. Today, let us break down why so many APIs suddenly stopped taking your password and the one change that actually fixes it. An integration that worked fine yesterday suddenly fails with a 401 today. That status code just means access was denied. Nobody on your team touched anything. You open the docs and one line has changed. Password authentication is no longer supported. There are really just two things to fix. You add one step in front of the call to fetch a token, and you change one line in the header from the password to the token. That is the whole change. There is one more part. Most people try to build a login screen here, but you do not need one when one server is calling another. You will also learn why you can skip it. So why does a password method that worked perfectly just disappear completely? The reason is simpler than it looks. The reason password login is going away comes down to one thing. The password goes out with every single request. If you make 10,000 calls a day, your password goes out 10,000 times. The old way was simple. You put your username and password right into the request header and send them. This is called basic authentication. It is usually wrapped in something called base 64, which makes it look encrypted. But base 64 is not encryption. It is just a way of writing, and anyone can turn it back in one step. So there are three weak spots. First, the number of times it is exposed equals the number of calls. Second, there is no expiry. Once it leaks, it stays valid forever until a human changes it by hand. Third, there is no scope. Whoever has it can do everything that account can do. And this is not just one API being difficult. OAuth 2.0 is not some new technology. It has been the standard way to handle authorization since 2012, and nearly every major API runs on it, from sign-in with Google on down. And right now, the big tech companies are leading the move. Microsoft removed password login from its own email platform, and now it cannot even be turned back on. Google also ended the old way of reaching your email and contacts with just a password. So this is not a passing trend. It is everyone moving to a standard that is already proven. So what actually changes in the call itself? It comes down to one structural shift, and it fits in a single picture. OAuth changes just one thing. You stop sending your credentials with every call to the API and send them to a token issuer only when you need a token. Before, it worked like this. Your server put the username and password into the request and sent it to the API. Every single time. Now it becomes two steps. First, your server sends the credentials to the token issuer and gets back a token with an expiry on it. That happens at the start, and again, only when the token expires. After that, your server puts that token into the request and calls the API. It keeps using that token for as long as it is alive. The credentials only go to the issuer. They never reach the API, not even once. So now there are two addresses in the docs, the one you get the token from and the original API. That is why there is a separate token URL written in there. And in the code, the one thing that really changes is a single header line. The line that started with basic now starts with bearer. The value you store changes too. Instead of a person's username and password, you use an ID and secret that belong to the app itself, called the client ID and client secret. And these credentials live on your server, never in the browser. The moment they reach the browser, they belong to someone else. Now, the docs will show you several ways to do this. Most people get stuck picking one, but really it comes down to one question. Is there a person in this call? If you are calling on someone else's behalf, you have to log them in and get their consent. That is the sign-in with Google that we all know. But if your server is calling with its own account, there is no person. No login screen, no consent screen. The server just quietly fetches a token. And this is where the idea that OAuth means a login screen falls apart. When it is server to server, that screen does not even exist. One everyday scene makes both of these steps click at once. It all happens at a hotel front desk. This whole thing clicks if you picture a hotel keycard. The old way is like showing your passport at every door. Your room, the gym, the lounge. At each door, you pull out your passport again. It works, but you end up showing your passport to strangers 100 times a day. And if you lose it once, it is not one room that is gone, it is your whole identity. And here the passport keeps working until someone changes it. The new way is different. At the front desk, you show your passport just once, and you get a key card. After that, every door opens with just the card. That card dies at checkout, it only opens certain doors, and if you lose it, your passport is still in your pocket. In this example, your passport stands for your username and password, the credentials. You hand them to the front desk, which is the token issuer, and you get back a key card, the access token. The doors that card can open are its scope. It stops working at checkout, which is its expiry. You reuse it instead of walking back to the lobby every time. And there is no name on it, which is exactly what bearer means. Whoever holds it has the rights. One everyday case. Your app sends email for your users, and you put the email account username and password into the settings. One day, it stops working. The way you send is exactly the same. Only the way you prove yourself has changed, and now it is a token. So you are not rewriting your whole code base, just the part that proves who you are. You have the whole picture now. Two things trip teams up the most. With OAuth, the token habits matter more than the code itself. Two mistakes catch people most often. First, fetching a new token on every call. This is the most common one. The whole reason a token has an expiry is so you reuse it in the meantime. If you grab a fresh one every time, your token requests grow with the number of calls. Then it stops looking like normal use, and you can hit a rate limit, the cap on how often you are allowed to call. When I have run an OAuth API myself, the callers doing it right reuse the token they already have and only fetch a new one when it expires or a key leaks. And the standard move is to grab a new one just before it expires. Second, treating the token like it is not a secret. Bearer literally means the one who holds this gets the rights. There is no name on the card, so whoever picks it up is the owner. So if you print the token into a log or paste it into a URL, it gets stolen just like that. It lives a shorter life than a password, but it is not any less secret. And that brings us back to that real cost. The code itself is one function. The hard part is finding, before the provider grace period ends, every bit of code and every batch job on your side that still uses the old method. The ones that work fine are quiet, so nobody looks at them, and they all break at once in the final week. So to answer when it will be done, you budget for that hunt, not the code. Here is how this judgment and the real cost actually sound on a real team, right at the kickoff of a switch like this.
We do not need a login screen here, right? The partner wants us on OAuth, but our server calls with its own account.
Right, no screen. There is no person in this call. We add one step to fetch a token, and the header changes. That is it.
So half a day then?
The code, yes. But first we check how long the partner keeps the old way alive, and then we hunt down every place in our code that still uses it. That part takes longer.
Once you get this far, a few questions always come up. 3 quick ones before we wrap. Are the client ID and secret brand new values you get issued? It depends on the provider. Some create new ones for you, and some tell you to keep using your existing account info. So check that item in the docs first, and you save yourself a wasted trip. Where do you store the token? Not in a config file. Your program just holds it in memory. The client secret is a long-lived value, so it goes in your config, but the token is short-lived and changes often. If it disappears on a restart, you just fetch it again. If you run many servers or some special setup, the answer changes, but that is outside today, and normally this is fine. There is also this thing called OIDC. Is it different from OAuth? Not really. OIDC just sits on top of OAuth. OAuth handles what you are allowed to do, and OIDC adds who you are on top of that. Sign in with Google lives on the OIDC side. That is the whole thing, folded into 3 short lines. 1. Not sending the password with every request. That is the whole OAuth switch. 2. In the code, one step gets added in front, and one header line changes. 3. If there is a person, you need a login and consent screen. If it is server to server, there is no screen at all. And that's everything for today. I hope this one helped. If it did, I'll see you in the next one. That's it from Gentle K. Thanks for watching, and remember, just start. It's easier than you think.